All right, it's time for LeetCode Contest 180. Okay, code review time. Problem 1. Okay, so first I didn't have time to do this last week, because I forgot about it. But I'll probably just, I haven't done it yet, but I'll probably just add in explanations later, towards the end. Okay, problem 1. It asks for lucky numbers in a matrix. Basically, it gives you a two-dimensional array, and it wants you to find all the lucky numbers, where a lucky number is defined as any number such that it is the minimum element in its row and the maximum in its column. So yeah, this is pretty trivial. Basically, what I did was I just bashed it, go through every element, and then for every element, check in its row and check in its column to see if it's the minimum in its row and maximum in its column. And if it is, then we add it to the list, and then at the very end, we just return the list. And oh, it says all elements are distinct. That could have helped. Okay, that's basically what I did. Very easy problem, no bugs. I solved this in solved this in 15 minutes, which is pretty long. Number 1. Problem 2, designing a stack with increment operation. So you make a class that implements a stack. It has a stack attribute and it has a maximum size attribute. Basically, if it operates like a normal stack, you can push and pop. If the size ever reaches maximum size, you cannot push anymore, but you can still pop. Yeah. Let's see. Pop returns -1 if the stack is empty, so I think maybe that's standard, but I'm not sure. So increment, basically you have to increment the bottom k by an integer value, and yeah, you just implement it. There's no tricks. Okay. Problem 3, balance a binary search tree. Okay, so the thing about binary search trees is that you can actually put all the elements into an array pretty fast using on, because you don't have to sort it because it's already a binary search tree. So you just do there's like pre-order, in order. So you do in order. Basically you do recursion from the left, and then you insert the value into the array, and then you do the right. So that's how binary search trees work. And then basically you have an array that's sorted, and then you go from the middle, you put that as the root, you take the left half of the array, and then you balance that, and then you put it as the left child of the root, and then you take the right half of the array, you balance that, and you put that root as the right child of the root, and then you return the root, and yeah, you use recursion for that. So that works. There's no tricks. Mostly, there's no edge cases. Yeah, and that works because everything's balanced, so like nothing differs too much. Problem 4, still can't figure out problem 4, and I'm just gonna give up on it. We'll just end here, even though the contest isn't completely over. So yeah, thank you. Goodbye. Yeah, so it was kind of a regular contest. I got ranked 1581, finished in about half an hour, but with no bugs. So kind of a good contest that I kind of did everything fast, but also I didn't finish problem 4. So that placed me below 1,000.